Our modern world is powered by electricity, but the phenomena of electric activity has been seen for millennia. Electrostatic charging formed by rubbing two objects together has been studied since ancient times, when Thales of Miletus discovered that rubbing amber on wool produced a static charge. And that's the start where many of our scientists and physicists learned about more in electricity priorly after Benjamin Franklin's extensive research in electricity, his famous kite experiment. Then, many scientists began contributing to our understanding of the electric activity. And one of the large breakthroughs in the history of electrical engineering is the discovery of electromagnetic induction by Michael Faraday, which demonstrates the first practical uses of electricity as a force that can be regulated to boost productivity starting in the 1830s. And let's see how he developed and discovered this electromagnetic induction. Let's have first a quick recall of electromagnetism. Electromagnetism is a branch of physics that deals with electromagnetic force that occurs between electrically charged particles. And there are two aspects of electromagnetism. One is electricity. Electricity is a flow of atomic particles called electrons. But sometimes electricity used to mean electrical energy, but no, they are not the same thing. Electricity is a transmission medium for wave energy that transmits to electrical energy. And the other aspect of electromagnetism is magnetism. Magnetism is the component of electromagnetism that involves magnets, magnetic fields, and magnetic forces. Magnetic fields are the region surrounding a magnet, and the electromagnetic force is the force that acts between charged particles and is a combination of all magnetic and electrical forces. This could be attractive or repulsive. And after that, the scientist Hans Christian Ørsted introduced us to the magnetic field, where the electric current induced magnetic field. Considering that we know the electric current induced magnetic fields, Michael Faraday's inquisitive mind wondered, could magnetic fields create electric current? Michael Faraday was an English physicist and chemist who greatly contributed to the field of electrical engineering, especially to the study of electromagnetism and electrochemistry. He invented the first electric motor and dynamo, and also discovered the effect of magnetism on light. Other than that, he discovered the peculiar behavior of certain substances in strong magnetic fields, which we call diamagnetism. In the year 1831, Michael Faraday made a groundbreaking discovery of electromagnetic induction. Electromagnetic induction is the production of an electromotive force across an electrical conductor in a changing magnetic field. Faraday observed that current is induced from the magnetic field and flows in the coil only when there is a relative motion between the coil and the magnet. According to Faraday's law, or the law of induction, a voltage is induced in a circuit whenever relative motions exists between a conductor and a magnetic field, and that the magnitude of this voltage is proportional to the rate of the change of flux.
What we have here is an electromagnet. So what is an electromagnet? Electromagnet is a type of temporary magnet that we can create by running electrical current through a wire around a ferromagnetic object. And today, we're going to look at a really simple way that we can make small electromagnet and use it to magnetize ferromagnetic object. In order to do this, we need a battery. What I'm using here is a 9V battery, an iron nail, magnetic copper wire, and the flat sheet itself that we're going to attract by the use of the electromagnet that we make. By making an electromagnet, what I did here is I coiled the wire around the nail. We said that the way an electromagnet creates the magnetic field is by moving electricity through a coil of wire. So I got the flat sheet here above the electromagnet, and all we're going to do is after I coil the wire, I put the first end of the wire against the positive end of the battery and place the other end of the wire against the negative end of the battery. That's going to create an electrical circuit. So that means the electricity is able to flow through the wire, and that's going to give us a magnetic field. As you can see in the video, our electromagnet attracts the ferromagnetic object, which is the flat sheet. Because again, we're generating that magnetic field from electric current running through our coiled wire, creating the temporary magnet. As you can see, it loses its magnetism when it's not connected to the battery. It has to have its own switch and off switch, that electrical current flowing in order to be a magnet.
This is a credit card, a thin rectangular piece of plastic or metal provided by a bank or financial services company. It basically allows its holders to borrow money from them, and since it involves money, companies added additional security features to prevent stealing or theft. So, how does it actually work? First, in front of the credit card, you'll see the chip, card number, expiration date, and the holder name. At the back of the card, you'll see magnetic strip along with signature, CVC code, and more. This magnetic strip is made out of ferromagnetic material, and it is capable of storing data by modifying the magnetism of tiny iron-based magnetic particles laminated on the card. It is also called as magnetic stripe or mag stripe. And to read the information that it holds, the card is swiped through the card reader that has a cylindrical coil called solenoid. When a card passes through the solenoid, it causes a change in the magnetic flux. The program then translates the change in magnetic flux into equivalent information.
Some computer hard drives apply the principle of magnetic induction. Recorded data are made on a coated, spinning disk. Historically, reading this data was made to work on the principle of induction. However, most input information today is carried in digital rather than analog form. A series of 0 or 1s are written upon the spinning hard drive. Therefore, most hard drive readout devices do not work on the principle of induction but use a technique known as giant magnetoresistance. Giant magnetoresistance is the effect of a large change of electrical resistance induced by an applied magnetic field to thin films of alternating ferromagnetic and non-magnetic layers. It is one of the first large success of nanotechnology. Hard drive use magnetism to store information in a layer of magnetic material below the surface of the spinning disk. The information is stored in the magnetic layer by creating small magnetic domains in this material. Magnetic domains are regions of the material which have the same direction of magnetic moment.